I'm trying to vary up my greeting. um, okay, so we're doing review of an Aztec interdisciplinary software material. My notes. We're doing mathematics section currently. We're learning about ratios and how to solve problems using ratios and proportions, which are like fractions comparing two things. Proportions. The example we just did was if 5 miles is to 10 minutes, and 30 miles is to X number of minutes, and you want to solve for minutes. So if you know that you're traveling 5 miles in 10 minutes, how many minutes does it take to travel 30 miles? And they did 5 miles over 30 equals 1 over 6. 5, well, yeah. And then they said equals to how many? 10 minutes over X. And then they solve for X, you get 60 minutes is done in 30 for 30 miles. It takes 60 minutes. So regardless of how you set up the fractions, you're gonna, if you have 3 pieces of information and you solve for X, you should get the right answer. So if you use cross product rule, that means you just you flip the denominator on either side to the opposite side. So instead of becoming from the denominator, it becomes the numerator. So you multiply on the opposite side. That's cross product rule to get X. Summary. 1, you find what you want to compare. 2, you pick the numbers that stand for that comparison. Then 3, you show the numbers as a ratio, or you simplify if they're not simplified using the greatest common factor, and you make sure the number the number divides evenly into all your numbers and your ratio, the greatest common factor. So you have things you're comparing, and you have numbers that stand for those things, and you have to simplify using the greatest common factor. That's for ratios. The next section is about patterns. Patterns are something you have to understand and to identify. This is things such as predicting the next number in a sequence. You can use patterns to complete input and output tables. Like if you have, you're given a bunch of data in a table and a few are missing, based on the ratios that you know between the input, which is in one column, and the output, which is in the second column, you can guess the missing numbers based on the ratios and the fact that you know the information is consistent in those tables. So you have to look for patterns and ratios to find missing data. So a pattern is a series of something, or repeating something. Ratios that repeat. It could be pictures, numbers, whatever is given. It can be in symbols, shapes, also for patterns, not just numbers, but anything that can be guessed or predicted from what you're given. For anything repetitive or consistent that you're given, you can figure out the pattern. So it's going to have some kind of a rule, the pattern, basically. So you use the matching, use differences, repeating, in order to make predictions. Numbers can be ascending or descending. For example, a pattern can be add a number, subtract a number, divide by a number, or multiply by a number. So input and output values are numbers that are in 2 columns of a table, but in the same row. The number in the first column is called input value. In the second column, it's called output value. The next section is about linear equations. When you have more than one, it's called a system. So more than one linear equation can be graphed, and you can solve these system of equations by either graphing and also by substitution, like using algebra, like with the variable solving for variables, and that we learned about earlier, with isolating the variable and plugging it in, finding x and y. That is solving a system of equations. So if you have x and y, you're going to have two equations with x and y. If you have three variables, which means you have three lines, so each line stands for an equation, you will have x, y, and z. But you will use the same process, and you will first isolate one variable, plug it into another, then plug that into the other, and plug them back in, and you will end up finding x, y, and z, for example. I guess that would be is that like 3 dimensions? I don't know. A linear equation has with one variable, so if you have one variable in an equation, like it says a linear equation with one variable has many solutions or points. So usually if you have two equations, like with x and y in both of those equations, you can solve, like I said, and then and sometimes you can have more than one possible solution, I think. Is that right? Okay. The example is this: y equals 2x plus 3. A possible solution is 1, 5. If you substitute, you get 5 equals 5. So since you get an equality, that means the point is, like, 0.15 is the solution to that equation. And the point is therefore on that line. So if you have an equation for a line and you're given a coordinate, you can know that is that on that line or not. And the way you do that is plug it in, the x and y values. If you get an equality, you know that that point is actually on that line and not just a random point on the plane. Okay, so if the point, if you don't get an equality, the point does not fall on that line or that equation. It's not a solution for that equation. So, like, one equation can have multiple points that can fall on that line. So for that line, -2, -1 is also a solution. If you plug it in, it'll come out balanced. So for an unbalanced equation, which is called a false statement, the point that you plug in for x and y will not work out. For example, the point -3, 4, when plugged into that equation, gives you 4 equals -3, which is false, a false statement. Therefore, the point is not a solution of that equation or is not on that line for that equation. Another example, if you have equation y equals -4 plus 9, if asked, is 4, -7 a solution for that equation? You plug them in, you get -7 equals -7. Therefore, if the equation comes out balanced, it is in fact on that line, the point. Another one, y equals 1/2 x minus 1. Asked if -2, -1 is on that line. The answer you get is you get -1 equals -2, which is not a solution.